Sp3 Hybridization Explained. In this lecture, you will learn Sp3 hybridization in the simplest way possible. After watching this video, you will completely understand how Sp3 hybridization works in different molecules. First of all, you need to understand what is hybridization and how we can define it. Actually, hybridization is a process in which different atomic orbitals with different shape and energy intermix to form new set of orbitals. Having same shape and energy is called hybridization, and orbitals obtained are called hybrid orbitals. In simple words, when atomic orbitals mix together, they form new orbitals called hybrid orbitals. Now, let's move towards types of hybridization. When s and p orbitals mix together, three types of hybridization can occur. First is sp hybridization, second is sp2 hybridization, and third is sp3 hybridization. In this lecture, we will understand sp3 hybridization in detail. First of all, we need to define sp3 hybridization. The type of hybridization in which one s and 3p atomic orbitals intermix to form four sp3 hybridized orbitals is called sp3 hybridization. This means one s orbital and 3p orbitals combine to make four new sp3 orbitals. To understand sp3 hybridization completely, we will study three important examples. In the first example, we will see sp3 hybridization in methane. In the second example, we will understand sp3 hybridization in ammonia. And in the third example, we will learn sp3 hybridization in water molecule. These three examples will make the concept crystal clear. Let's start with first example, which is sp3 hybridization in methane. Let us start with methane molecule. The formula of methane is CH4. In methane, the central atom is carbon. Carbon shows sp3 hybridization in methane molecule. Now, let me show you the electronic configuration of carbon. The atomic number of carbon is 6, so it means carbon has 6 electrons. The ground state electronic configuration of carbon is 1s2, 2s2, 2p2. In this ground state, carbon has only 2 unpaired electrons in 2p orbitals. But in methane, carbon forms 4 bonds with 4 hydrogen atoms. So carbon needs 4 unpaired electrons. So, to get 4 unpaired electrons, carbon gets excited. When carbon gets excited, 1 electron from 2s orbital jumps to the empty 2p orbital. Now the excited state electronic configuration of carbon becomes 1s2, 2s1, 2p3. In the excited state, carbon has 4 unpaired electrons. 1 electron is in 2s orbital, and 3 electrons are in 2p orbitals. Now hybridization takes place. When an electron moves from ground state to excited state, the orbitals that mix together give us the hybridization state. Here in excited state, 1 2s orbital and 3 2p orbitals are present with unpaired electrons. These 4 orbitals mix together, so 1 s orbital and 3p orbitals undergo hybridization. Therefore, the hybridization of carbon is sp3. After hybridization, 4 sp3 hybrid orbitals are formed. All 4 sp3 orbitals have same shape and same energy. These 4 sp3 orbitals form 4 bonds with 4 hydrogen atoms. The shape of methane molecule is tetrahedral. The bond angle in methane is 109.5 degrees. Now, let us understand the second example. That is ammonia molecule. The formula of ammonia is NH3. In ammonia, the central atom is nitrogen. Nitrogen also shows sp3 hybridization. The atomic number of nitrogen is 7, so it means nitrogen has 7 electrons. The ground state electronic configuration of nitrogen is 1s2, 2s2, 2p3. In this ground state, nitrogen already has 3 unpaired electrons in 2p orbitals, which means 1 electron in each 2p orbital. Now here is an important point. In ammonia, nitrogen forms 3 bonds with 3 hydrogen atoms. Nitrogen already has 3 unpaired electrons in ground state, so nitrogen does not need to get excited. There is no excitation in case of nitrogen, but the question is, why no excitation takes place? The answer is simple. Because nitrogen already has enough unpaired electrons to form bonds. Also, all 3 2p orbitals are already occupied. There is no empty 2p orbital available, so electron cannot jump to 2p orbital. Therefore, nitrogen remains in ground state only. Even though there is no excitation, hybridization still occurs. In nitrogen, 1 2s orbital and 3 2p orbitals undergo hybridization. So the hybridization state will be sp3. After hybridization, 4 sp3 hybrid orbitals are formed. Out of these 4 sp3 orbitals, Three orbitals have one unpaired electron each. These three orbitals form three bonds with three hydrogen atoms. The fourth sp3 orbital contains a lone pair of electrons. This lone pair does not participate in bonding. The shape of ammonia molecule is trigonal pyramidal. It is not tetrahedral like methane because one position is occupied by lone pair. The bond angle in ammonia is approximately 107 degrees. Now let us discuss the third example, which is water molecule. The formula of water is H2O. In water, the central atom is oxygen. Oxygen also undergoes sp3 hybridization. The atomic number of oxygen is 8, so oxygen has 8 electrons. The ground state electronic configuration of oxygen is 1s2, 2s2, 2p4. In this ground state, oxygen has 2 unpaired electrons in 2p orbitals. The remaining 2 electrons in 2p orbitals are paired. In water, oxygen forms 2 bonds with 2 hydrogen atoms. Oxygen already has 2 unpaired electrons, so oxygen does not require excitation. Oxygen remains in ground state. So again, the question is, why does oxygen not get excited? The reason is that all 3 2p orbitals are already filled. There is no empty 2p orbital available for electron to jump. If an electron tries to jump, it needs to go to 3s orbital, which requires very high energy. So excitation does not occur in oxygen. However, hybridization takes place even without excitation. 1 2s orbital and 3 2p orbitals of oxygen undergo hybridization. So, the hybridization will be sp3. 4 sp3 hybrid orbitals are produced. Out of 4 sp3 orbitals, only 2 orbitals contain unpaired electrons. These 2 orbitals form 2 bonds with 2 hydrogen atoms. The remaining 2 sp3 orbitals contain lone pairs of electrons. The shape of water molecule is bent or V-shaped. This is because 2 positions are occupied by 2 lone pairs. The bond angle in water is approximately 104.5 degrees. Now at the end, let's have a look at the summary of all 3 examples. I will summarize all 3 examples for you. In methane, carbon undergoes excitation from ground state to excited state. 1 electron jumps from 2s to 2p orbital. Then sp3 hybridization occurs. Methane has tetrahedral shape. In ammonia, nitrogen does not undergo excitation. It already has 3 unpaired electrons. Nitrogen directly undergoes sp3 hybridization in ground state. Ammonia has trigonal pyramidal shape due to 1 lone pair. In water, oxygen does not undergo excitation. It already has 2 unpaired electrons. Oxygen directly undergoes sp3 hybridization in ground state. Water has bent shape due to 2 lone pairs. In all 3 molecules, sp3 hybridization occurs, but the process is slightly different in each case. In methane, excitation happens first. In ammonia and water, no excitation is needed. Therefore, sp3 hybridization is the mixing of 1 s orbital and 3 p orbitals to form 4 sp3 hybrid orbitals. This concept is very important for understanding molecular geometry and bonding.